The one-way chi-squared, also known as the chi-squared goodness of fit. It's used to assess whether the observed membership frequencies differ from the hypothesized or the expected membership frequencies. So they hypothesized frequencies can either be equal. What means is that all categories will have the same number of participants, as in the example I should provide, or they can have unequal hypothesized frequencies. Now, the first three assumptions are largely methodological and should be managed in the following and throughout the data gathering stage. The fourth assumption is one that is calculated by SPSS, or you could do it by hand like we did in the previous lecture.
Hello, this is the alcohol. What I've done is I've opened up the alcohol data, which is in this week's lecture, just so that you can see how the data analysis is done in a chi-squared analysis, a one-way chi-squared analysis. So what you can see here is that there are two columns. The first column is the brand, and the second column are bottles. So if I was to have a look at variable view, you can see the brand is a brand of bottle purchased. And you know that is either absolute excite, so it's exciting advertising, absolute colour, so it's colourful advertising, or absolute bore or snore. I know I've used both terminologies, but that's basically advertising that'll put you to sleep. So then we also have the second column, which is the bottles purchased. So it's the number of bottles purchased in the sample period, in the time period that it was being recorded. So if I go to data view, now the first thing to notice is that in the time period that the bottles were purchased, I can see 140 bottles purchased of absolute excite, 105 bottles of absolute colour, and 55 bottles of absolute bore or snore. So the first question I want to ask is, are these significantly different? So what I'm going to do is I'm going to compare those bottles to an expected value if they weren't different. So the expected value, if they weren't different, would be that you get 100 bottles in each category, isn't it? So to do that, what I'm going to do is I'm going to do a chi-squared, a one-way chi-squared. But I've noticed I've got frequency counts here. So the first thing I want to do is go to data and weight cases. And I'm going to weight cases by number of bottles. So your textbook explains why we weight cases. And I'll go OK. And I'll come back to the data set again. Now I'm going to conduct the one-way chi-squared analysis, comparing those frequency counts, 140, 105, and 55, to whether, to the hypothesized value of being equal counts in equal number of bottles in each category. In other words, I'm comparing it to 100 in each category. So if I go to analyze, now the chi-squared is a non-parametric test, so I go to non-parametric tests, legacy dialogues, and I click on chi-squared. So what I've got there is my variable of interest, which is the number of bottles purchased, or it's that variable there. I'm going to pull that over, and I'm going to assume all categories are equal. So in other words, 100 bottles were I'm assuming that the expected number of values is 100 in each category. And I'm going to go, I've got a couple of options there. I've got the exact, we're just going to leave it like that. We've got the options there. Look, I'm just going to leave it like that and press OK.
Now in this table you see the observed N, the expected N, and the residual. The observed N. This is the number of cases we observed in each category. The column basically just replicates the data file, or summarizes the data file. So we've got 55 young people who bought absolute bore, 105 young people who bought absolute colour, and 140 young people who bought absolute excite. The expected N, or the expected number, these are our hypothesized frequencies, the pattern of responses we would expect if all three types of advertising were equally popular. And the residual, this is just the difference between the categories observed, N, and the expected N. Now the test statistics table contains the results of the chi-squared test and answers the basic question: do the observed frequencies differ from the expected frequencies? Now it takes the observed number and the expected number and puts it into the following formula. Now because the asymptotic sig is less than 0.05, which is our nominated alpha level, the answer to the question there is a significant difference between the observed and the expected frequencies. Make a note of these frequencies or these figures for write-up. These are the chi-square statistic, the degrees of freedom, and the significance value. Now, the note below the test statistics table informs us that 0% of the categories had expected frequencies below 5. So the expected frequencies assumption has not been violated. If the assumption is violated, if your expected frequencies are below 5, our best recommendation is to 1, increase your sample size, or 2, think about combining or merging some categories.